pressure graph shows the relationship between the temperature and pressure of a fluid. This particular graph is produced from data that is specific to water. However, similar looking vapor pressure graphs are available for all fluids. Notice the vertical axis, or the y-axis of the graph, is used to plot the pressure of the water, and the horizontal axis, the x-axis, is used to plot the corresponding temperature. Notice that this upper portion of the graph is labeled as a liquid, and that this lower section is a vapor, or a gas. This line is known as the vapor pressure line, or the vapor pressure curve, and it identifies the point of transition from a liquid to a gas, the process that we typically call boiling. Remember this term vapor pressure line, as I will refer to it again in a moment. To see how this graph works, let's use a couple of examples. For example, many people, when asked if they know the boiling temperature of water, will answer that it boils at 212 degrees Fahrenheit. This answer is partially correct. As shown by the graph, water does boil at 212 degrees Fahrenheit at the standard atmospheric pressure at sea level of 14.7 psi. However, notice that the boiling temperature of water changes with its pressure. In general, lower boiling temperatures correspond with lower pressures, and higher boiling temperatures correspond with higher pressures, as we can see on the graph. Typically, if we want to boil water, we add heat in order to raise its temperature until it reaches the boiling point. We can demonstrate this process on the vapor pressure graph. Let's say, for example, that we pick a point at random on the graph. Let's say that it is right there. If we cause the water that is at that temperature and pressure to boil by raising its temperature, we can graph that by drawing this straight line, by starting at its current temperature and pressure and ending at the boiling point. Here is a short animation that visually illustrates this process. In this animation, this part represents a cylinder, and it is partially filled with water, shown here. This represents a piston. Imagine that the piston is tightly fitted to the cylinder so that there are no leaks in the system. Now, as we add heat to the cylinder, the temperature of the water will increase, as expected, and at some point will begin to boil. During the boiling process, the water changes phase from a liquid to a gas, otherwise known as steam. Now, as I start the animation, we can see that the expanding steam in the system raises the piston, as expected. Now, I'll pause the animation momentarily. At this point, notice that our system contains a liquid, water, a gas, the steam or water vapor, and also these bubbles that are in the process of transitioning from a liquid to a gas, exactly as we saw in the vapor pressure graph. In the next step of the animation, I'll turn off the heat to allow the water to cool.